Hey guys, it's Coach Spartman here. We're still talking about data and statistics. This is student handout number 6. Box plots. A box plot displays a data distribution using 5 key numbers. The difference between the first and third quartile is called the IQR, which we've talked about, which is the inter-quartile range, which is a measure of variability, which we did the other day. All right, so it gives us 5 pieces of data. First one, the smallest piece of data we call the minimum. That's pretty easy to find, right? The second part of the data is the first quartile, which we also refer to as Q1. Okay, the median. The median of the upper half is called the third quartile. All of this we've talked about, so this is nothing new here. Okay, and then we have the maximum. Again, you've done every bit of this, okay? So here's what each one of those datas mean when you look at the box plot. This is the minimum right here. That's the minimum. Q1. Okay. Or right there, whatever. Let's redo that. The median. Q3. And then the last little part is the max. All right, so you have the minimum, Q1, the median, Q3, and the max. It's the 5 numbers they're going to give you. So it's real simple. All right, so the following data set represents the number of book pages read in a day. I'm going to go ahead and rewrite them because we're going to have to rewrite them. So I'm going to go ahead and start with 19, 30, 32, 33, 34, 34, and 35. All right. What is the minimum of those numbers? Obviously, it is 19. The maximum, obviously, is 35. So now let's find the median and kind of start. The median is 33. All right. Now look at Q1 and Q2. Q1 is right here. And the middle point of that one is 30. All right. And the third quartile and the middle point of that is 34. Now all you have to do is go draw that box plot. So what that means is start on the minimum, which is 19, which is right there. So that's where your line's going to start, right there at that dot. Okay. Your Q1 is your next one. That's where you're going to make your box. So that's right there at 30. The median is where your line is going to be, and that's at 33. So 33 is right there. So that's going to be your line. This is going to be your box. And the Q4 or Q3, excuse me, is 34. So 34 is right here. So we're going to continue our box there. Our max is 35, so we're going to go to that point, and then we're going to connect our minimum dot. And that's how you create a box. So I'm highlighting the minimum, and then you just draw the line to the first Q1. And then you have Q1 to the median. And then you go from the median to Q3. And then on the back side, you go to the max with the line. That's it. So I'm gonna pause now and let you do number 2. Same exact thing, except now you have decimals. So when you have decimals over here, let's say one of the decimals is 2.8, okay? What do these right here represent? Well, this is a whole number, okay? So how many of these are there? There's 4 of these, okay? So if there's 4 of these, they are 2/10 apart, okay? So each one of these are 2/10 apart. So this would be 3.2, 3.4, 3.6, 3.8, so forth, all the way across, okay? All right, so you do that one. Pause it now. All right, come back. Let's rewrite our numbers here, smallest to largest. Smallest one, it looks to me, is 3.2. The next one is 3.8, 4.1, 4.2, 4.7, 5, and 5.8. All right, find the median. All right, let's go ahead and do the minimum first, since we can do that one pretty easily. Minimum is 3.2. Maximum is 5.8. All right, now let's find the median. Middle number is 4.2. Let's find Q1. It's these 3 numbers, so go to the middle there, and you get 3.8. The next one is these 3 numbers. Go to the middle there, and you get 5. Perfect. Now, come down here, and the minimum is 3.2, so you're gonna go right here. The maximum is 5.8, which is right here. You can just put dots there for now. Now, Q1 is 3.8, so I'm gonna go to 3.8 and start my box. There it is. And the median is 4.2, so I'm gonna go to 4.2. There's where my box is gonna split in half. And Q3 is 5, so I'm gonna go all the way to 5. Right there. Now I'm just gonna connect my box and connect my lines. All right. And what a handy dandy laptop iPad right there, helping me out by erasing everything I just wrote. All right. So I was at 3.2, 3.8, 4.2, 5, and 5.8. There we go. 5.8. Give me just a second while I recreate this. All right, there we go. All right, yours should have looked something like that. Maybe a little better than mine, but pretty much exactly like that. So if they ask you to create a box plot, that's what they're asking you to do. 5 pieces of data, minimum, maximum, median, and Q1 and Q3. All right, use the given blocks plot to determine the 5-number summary. I'm gonna let you do that. Ready, go. All right, welcome back. The minimum is right here. That's 18. Maximum is right here. So in between these is probably 25 and 26. That's closer to 25. So the maximum is 25. The median is exactly on 21. That one's pretty easy. Q1 here, let's do it, I'll do it in yellow here. Q1 here is right in between right there. Well, there's two numbers supposed to be in between there, 19 and 20. That looks like it is on 19. All right, now to Q3 here in red, it goes down right there. What numbers are in between there? So 22 and 23. So it looks like it is on 23. So 18, 19, 21, 23, and 25. All right, to the back. You're going to use the box plots right there, okay, to answer the questions below. So in a local election, a school bond is proposed to fund a natatorium. I don't even know what that is. Let's ask Siri what that is. Siri ain't gonna answer me. Oh, I think I can press this button. It's a swimming pool. Okay, never knew that. New information for me. Anyways, Alex conducts an exit poll in which he asks voters to share their age and whether they are for or against the school bond. He then displays the data in a box plot. What is the difference of measure of center of voters who are for and against the natatorium? What is the measure of center? The median, okay? So what is the median of 4? Just go straight down. That looks to be 31, 32, 33, 34, 35. Okay, so you can write that there, 35. And over here on the other one, it is right there, which is 49. So what is the difference in the median of each one? The 4 is 35 and against is 49. So the difference is 14. So the difference in measure, AKA median, is, measure of center, my bad, is 14 years. Determine the IQR of voters who voted against the natatorium. Determine the IQR of voters who did not. All right, who voted against and for. All right, so to find the IQR, we have to find Q1 and 3 and then subtract, okay? So let's find Q1 and Q3. Let's start with 4 up here. Who's for it? Okay. All right. Q1 was 28. Q3 is 42. Subtract those and you get 14. Okay? All right. Now let's go to the other one, the against people. Q1 is 40. Q2 is right at 60. I'd say 60. Subtract those two and you get 20. Okay? So it said determine the IQR. So let's go down here. The IQR for people who are for The vote is 14. The IQR for people against the vote is 20 years. So what that tells us is the people who voted for it are closer in age than the people who voted against it. The people who voted against it are all the way from are a crazy amount of range of ages, where the people who voted for it are kind of younger. The older people don't want the pool, the younger people do. That's what it amounts to. Okay? So let's complete the statements below. The range and age of voters for the natatorium was blank than the range and age against the voters against it. All right, so 4 was 35 was the median, and the other one was 49. The IQR was 14, 4, and 20 against. So it is less than the age of the people against it. Younger people wanted it, older people didn't. The IQR of those who voted against the natatorium was almost how many times? Well, how many times will 14 go into 20? Okay, just enter that in your calculator real quick, and I'm going to do the same on mine. $20 goes in first, by the way. You come out with roughly 1.4, which is almost 1.5 times, which is almost 1.5 times the IQR. All right, question 7. I want you to answer these. I'm pausing now. Use the box chart right here. All right, pausing now. All right, welcome back. All right, a survey was conducted to determine the average price of a movie ticket in Kansas and New Jersey. The data displayed using the box plots shown below. All right, so let's go ahead and just figure out the minimum and maximum here. For Kansas, since I have a ruler, I'm going to use it. Okay. Kansas, the minimum was 4. Q1 was 7. Median was 10. Q3 was 11, roughly. And maximum was 15. All right. New Jersey. I'm going to say that's 4.5 was the minimum. I'm going to say that's 8.5. Uh-oh, my ruler went away. I'm going to say that's 11. And I'm going to say that is 16. And maximum is 19. All right. What was the median cost of a movie ticket in each state? Median is the middle there. So it was what? 10. So Kansas was 10. And New Jersey was 11. Which state has a wider range of variability? Well, if we look at them, which one has a wider range? It's pretty easy to see, right? New Jersey. New Jersey appears to have a wider range and variability because, here's the important part, because it has a wider spread. And then if you want to be technically correct, you put spread of data, but you could just put spread. Okay, if you look at it, you can see that the data goes all over the place. I mean, it goes from way out here, 19, all the way to 4.5. So that's 14 and a half, where the top one, Kansas, only goes from 4 to 15, which is only 11. Okay? All right. Now, just because the minimum and maximum, you really, okay, the Q1 and Q3 will kind of tell you how spread out it is. All right, C, a moviegoer spends $14 on a movie ticket in New Jersey. What can you conclude about the price the customer paid? Okay, he spent $14, which is right here. He spent more than the median cost for a ticket. Okay, he spent $3 more. So if he went somewhere else, he might could have paid cheaper. Okay, so what I want you to notice is the moviegoer spent, hey, we'll just put a few more dollars. More than the median. Cost. The moviegoer spent a few more dollars more than the median cost for a ticket. The moviegoer spent a few more dollars more than the median cost for a ticket. All right, it's all for the fat guy in the back. I'll see you on the flip side. Adios, amigos.